Alright, and welcome back, and we're on question 58 now. And it says a triangle ABC, is reflected across the x-axis to have the image triangle A prime, B prime, C prime. So we have triangle ABC, gets reflected across the x-axis, and then they're calling the new triangle A prime, B prime, and C prime. And so it says thus A reflects to A prime. The coordinates of point A are C, D. What are the coordinate of points A prime? So in this triangle, the point A had the coordinates C and D. And then after we flipped it across the x-axis, the point A prime had some other coordinates. It wants to know what are these coordinates, these two coordinates. Question mark, question mark. Okay, so we know that we have the triangle somewhere anywhere in this coordinate plane. It doesn't matter where we pick. Say we pick right here, and say this is point A. Then this is point CD. A is point CD. So if we flip it across the x-axis, it'll look like this, and this will be point A prime. So the only thing we changed is the point A still goes, here I'll change the color here, point A still goes this far over on the x-axis, right? Still goes this far over on the x-axis. So point C is the same, but now, whereas point D, or this is point C, and now, before point D went positive, or point A was positive units up, and now point A prime is negative D units down because it's flipped over, right? We just had this point on the coordinate plane up here, and now we put it down here. The only thing that changed is its y coordinates went from positive to negative. So we can say the A prime has points C, negative D, which is choice A. So we could have really placed this triangle anywhere. Say we place the triangle down here. This is on this graph. Then when we flipped it over the x-axis, it would look like this, and its C coordinate, or its x coordinate, would still be the same. Say it was like this, A prime. Its x coordinate would still be the same, but again, its y coordinate is just flipped, it's opposite, which explains the negative D. So we'll go on to question 59. 59 says, if x is equal to 2t, 59, if x is equal to 2t minus 9, 2t minus 9, and y is equal to 5 minus t, which of the following expresses y in terms of x? So they want an equation that has y solved for, but in terms of x. So we have two equations and three variables. So we can solve for this. We can solve for either equation in terms of t, and then plug that value in to the other t, and then we'll have just the x and y variables. I'll show you what I mean. So if we solve this equation right here, in terms of t, we'll have t is equal to, well, y, negative t is equal to y minus 5, and then t is equal to negative y plus 5, and then we can plug in this t right into here, so we'll have x is equal to 2 times this t, but this t is just equal to negative y plus 5, so we're just substituting that in. So negative y plus 5, and then minus 9 for the second part here. So now we can just FOIL this out, or not FOIL, but distribute. So that'll be equal to negative 2y plus 10 minus 9, which is equal to x. So, x. So we'll have negative 2y plus 1. And it wants us to solve this in terms of y, so we just need to isolate y. So we'll have x minus 1 equals negative 2y, and y will be equal to x minus 1 divided by negative 2. which is equal to negative x plus 1 divided by 2. Not sure which one they asked for, and they ask for this right here, this style. Either one of these should be correct, they're the same thing. So this is the answer, choice A. And we'll go on to question 60, and it has a chart, so I'll actually just skip ahead so you don't have to see me drawing it. So question 60. Alright, so this is a chart in question 60, and it says, what is sine of pi over 12 given that pi over 12 equals pi over 3 minus pi over 4? And then it gives an equation. So it wants us to figure out what the sine of pi over 12 is. And if you look at the answer choices, it gives it in exact numbers. So if you wanted to on the ACT, you could just plug this into your calculator in radian mode, and then just solve or check each answer, see if it matches up with it. But they also tell you that, or you don't have to do that, because they also tell you that pi over 12 is equal to pi over 3 minus pi over 4. And then they give you this equation that looks pretty daunting if you don't know how to work with it. So it says the sine of alpha minus beta, these are just two variables, is equal to the sine of alpha. Here, I'll actually do that below because it's going to take a lot of room. Is equal to the sine of alpha times the cosine of beta minus cosine of alpha times the sine of beta. Okay, so these are just two variables, and it says, basically it's saying when you have the sine of a term x minus a term y, it'll just be the sine of x times the cosine of y minus the cosine of x times the sine of y. So we can see that the sine of pi over 12, the sine of pi over 12 is equal to the sine of pi over 3 minus pi over 4. Right? Because pi over 12 is equal to pi over 3 minus pi over 4, so you can just substitute and you might be able to see where this is going. So if we let pi over 3 be equal to theta, do this up here, pi over 3, let that be equal to theta, which is this curvy thing, and if we let pi over 4 be equal to beta, which is b with a really long side, then we can use this equation. So then sine of pi over 3 minus pi over 4 turns into, I'll do it down here, this turns into the sine of pi over 3, times the cosine of pi over 4, and then that is minus the cosine of pi over 3 times the sine of pi over 4. And there is a proof for this, but that's beyond the scope of this problem. I'm sure you'll learn it in pre-calculus. So this sine of pi over 3 minus pi over 4 is really just equal to this right here, this equation. And we have all the exact values for this, so we can just plug it in. So sine of pi over 3 is the sine of pi over 3 is equal to the square root of 3 over 2. The cosine of pi over 4 is equal to the square root of 2 over 2. Multiplying these together, and the cosine of pi over 3 is 1/2, and the sine of pi over 4 is, the sine of pi over 4, is square root of 2 over 2. So now we can just multiply this out, and we'll be left with the square root of 6 divided by the square root of 6 divided by 2. Or excuse me, that's square root of 6 divided by 4 minus the square root of 2 divided by 4. So let me change colors a second so it doesn't get confusing. So this equals the square root of 6 minus the square root of 2 all over 4, which is the answer. So, well, actually that's the last problem we have for this ACT test. I hope you enjoyed the journey. I hope you learned a lot. Take this into your next ACT, and I'll probably just do a wrap-up video after this to go over some of the concepts we learned. And yeah, I'll see you in the next video, I guess. Hope you enjoyed this.